Hello, good morning, happy Monday. How you all doing today? I am looking forward to continuing this project continuing to figure out how to get the commit from what we queried from the server. And I was looking at this a little bit before stream. It looks like they have this commit here that they're trying to find this from the git objects directory. And so we've initialized the directory. That was great, but we clearly need the next thing. So that is what we're going to work on today to see if we can grab that out of the query that we got previously. Now, this is that query that we got. So we can see when I went to my learning game design patterns repo, this is what we get out of it. So a lot of binary stuff. Now, my guess is that most of this is, I think most of this is compressed, but then there's going to be a lot of binary files in there too. So it's basically compressed and then binary compressed, and so probably like multiple layers of stuff, which is lots of fun. Asitsu, hello. How are you doing today? Happy Monday. I also attempted to create some cut videos and put them up. I've also created a few shorts and put them up too. Unfortunately, part 3, I think, and 4, or maybe 4 and 5, I can't remember, of this series did not encode correctly or something. YouTube couldn't process it, so I need to fix that. That's one of my things I'm working on. Happy Monday. I don't think so. I'm sorry. It is true. It is Monday. So I guess what's another word besides happy? What can we use to say, like, something happy and then something morning, and then that could be our new morning thing. Maybe we can like create a random word generator for that. All right. In the meantime, I'm not 100% sure what we need to do here besides maybe grab this out. Well, I think we were looking at the documentation last time, right? There's a few different things here. So this is the Git protocol pack. I don't think that's what I want, but maybe it is. How far did I get after you left? That would require me to have a memory good enough to remember when you left. I'm not 100% sure. So here's what we got so far. We've got the ability to in Insomnia is what we're using right now, which is a similar thing to Rapid API or Postman. It allows us to make requests and sort of check out what we got. So we're able to successfully get the pack request from GitHub. So we send a post request to github.com, hand it a repo, and also this git upload pack. We send it into the body. We send a 032, which what was that again? That was like oh no, this is the size. So we send it the size of how big this line is, and then the hash that we want, and then a new line, and then the same thing. So how much we're getting, what we want to get. So I'm asking for these 2 commits right now. And then we pass it in 4 zeros, so a null, like an end bit, and then a done, which all have to be together. We can't have a new line in there. So this was the thing that we were missing. Like, we couldn't get this to work because this was kind of documented, but not really. And then, bam, we get this back. You left after I started parsing right before you went through the files into the pack. Okay. So I don't think we actually parsed this, right? I don't think we parsed it. Maybe we did. I don't remember. Let's find out. So here's our code over here on the left. Let's full screen you. So in clone, so we figure out our current. We go from, okay, we have our current directory. Oh, we create a new directory and then we init that. That's what we did. And then we do our, okay, so then we could do our discover references. So pretty much what I probably want to do now is recreate this in code to get this out. So we want to discover our references. So here's our refs. And then we want to get commit, which is less of a commit, we now realize, and more of a pack file that includes that commit, right? So we want, okay, get commit with this to the URI. Now, if we come over here, we see, okay, we have our commit hash, we have the repo URI. Okay, I think that this is all good. Client new. We have our, okay, so we create our what we want in a body, which is this 0032 want, commit hash, new lines, 000, 009. Okay, great. Get you. Oh, Zilby's here. You wanna hang out with me? Hi. Come here. Come here. Yeah, we've got some food for him here, so maybe he'll like that. But maybe he wants to just be pet for a little while, or not. Okay. If he comes into sight of the camera, I'll put that on. Sylvie, your food is right over here. Hold on, let me show him his food. Okay, he's not interested in his food. I don't know what he wants right now. He's staring at the door, so he might just leave. Okay. Let's see. So we got a response back. Oh, we get you. We get our bytes, and then we return the bytes. Okay, so that makes sense. Now we get our commit, and so what would be nice is to save this to a file so we can inspect it, which I have the save to file, but I don't think that's exactly what we want to do here. I just want to save it exactly as it is to a file. So let's maybe just maybe dev save to file. I don't remember. I thought we did went through this, but can't remember. And do I have another file to do that with? I don't remember anymore. I thought we did too, but I did something. Now I'm thinking of going through the first part of the header and grabbing that out, which I think that we were also thinking of doing with this stuff, right? To say, okay, we want to now walk through the commit that we get back, like, you know, the head, the signature, and then everything else. So I think I was doing this wrong. I think what we were running into was that there was not very much documentation on what is in here or what it looks like. So we could attempt to look through documentation again, or we can just sort of use the pigsy command, I think. Was that what it was? Yeah, the pigsy command. So if I grab you, so you open, yeah, you open up a file and pass it into hexdump. Oh, and then, you know, if I print this out to the console to standard out, oh, but I can't do that. I can't print it out to standard out because it doesn't know how to print it. It will crash. That's why it has to be a file. So if I just save bytes to file, and so let's just make this like a test file or something. Can I push here? Oh, that's a path buff, right? Let's push, let's do just like test dot, maybe test file. Yeah, let's just call it test file. So we do that, then we're gonna, is it just write file? It writes into a buffer. Oh no, I think I have to get the file first. So we have the file open for writing. What do I do? Let's see. Oh, it's okay. So it's just standard F has write path and then whatever the bytes that I'm writing. Okay, that makes sense. So standard file standard FS. Right, we have our path, and then we have our data. The trait bound, nothing as ref path. Can you be a reference? No. You need to be a path. Do I have to into you to turn it into a path? Type annotations needed multiple input. So as, okay. Path doesn't return an output. Oh, yeah. Path buff. Oh, push doesn't. Oh, yeah, that's it. You're nothing. That. That would do it. That would certainly cause a problem. Okay, so now I can do dev save to file. So I don't have to like mess around with the other one we did previously. So we can do our dev save to file, hand it the commit, and then this will create a file named test, which we apparently, oh, test file, which will then show up right around here. So let's clone, get sample 3 again. Okay. And now we do not have a test file. Panicked at init. Oh, init panicked. Oh, it already exists because it already exists. Okay, yeah. I need to remove get sample 3 and do this again. Okay. Now here we go. So here's this test file. Now I want to use our Pigsy, and we're going to open up test file. Why did that? Test file has 21K of stuff in it. Oh, so Pigsy can't read it. So it's not output it knows how to read. So okay. So basically looking at this. Oh, you did briefly check in for a second after you left and you saw I had to get internals article open which had the solution. Did I have the solution? I don't remember having the solution for this, but maybe I thought we ran into a oh, it's not documented thing. So get internals. It was a pack file. I think there's a link to that from in here somewhere. Might be get upload pack like that. Oh, it was an article on dev too. Okay, hold on. Still have it in my history. Excellent. That's what we needed. Okay. Get internals part 2 pack files. Okay. This post continues the get internal series. We introduce Git's object storage model. This post will look at object storage in more depth, so I recommend, okay. First, we'll see that Git usually does not store objects the way we saw last time. We'll introduce the pack file, which is what Git uses instead. Then we'll look at the 2 parts of the pack file, the IDX and the pack. Oh, did we decide? Oh, I'm starting to remember now. I think we realized that the way this is working for us is not helpful because this is saying like we need the index to read through the pack. Because they dig into the index file. Look at the read type and the size method. Read type. Okay, so read type and size. Object type and compressed pack data size are stored in a size encoding variable length integer. Okay, so what section is this under? Reading an object from a pack file. Okay. So now this is after the index tells it where it is. After you parse the other headers in a file, you loop and call that to get the compressed sections. I guess that's the problem, is like, how do I get the other headers? Object type and uncompressed pack data size. Right. Okay. So, I mean, this is really jumping to where it is and then getting the next pieces, right? So, we already had those. Now commented out. I thought that those were failing for some reason. I thought we were failing to get these for some reason, but I don't remember exactly what was causing problems. But we can uncomment these out. Is that a word? Uncomment them. So grab these. Object type. This is trying to make it binary. The last little bit with the object type was wrong though. The trait U8 binaries aren't satisfied. Okay, so basically I can do it with a U8, but because this is an object type header, do I want this to be binary? Or do I just want this to be the object type? Oh, it doesn't implement display. Oh, because I'm trying to turn it into... Delete the object type. Okay, so if I delete the object type, then I need to delete the object type header. Which means I can't have these. Okay, so... Okay, commit, ref new. Okay, so we get this. Right after getting the count, you need to loop over the entries, and the read type and size function seems to be the solution. Okay. Oh, so there's going to be the count in there. Okay, so let's grab this. So we have our commit ref. We grab you, and then we debug you. Let's see if this is still working. No errors. Now, if I come over here, and I want to do a cargo run, clone this, but before I do that, we have to first delete. Come on, why? Oh, weird. What are you doing? Okay, so I want to go to, okay, in desktop, remove get sample 3, which I think is what we called it. Get sample 3. And then run this. Okay, so here's what we got. 302 objects. Which I think makes sense. That's the thing that we're getting. Okay, so we have 302 objects. Now, if I want to get the first of these objects, so the stream, I'm guessing, is the entire thing after everything else that we got. Object type and uncompressed data pack data size are stored in the size encoding variable. Okay, we're doing some fun bit shifting things to get through it. Now, to grab the, let's see. No, wait, don't I have, is this the size that I got though? The 302? Oh no, this is the size of the thing that I want to get then. Now, since this is variable length to get to this point, right? Where we have like our head signature version object count. We're going from the bytes. Okay, so that's 16 through 20, so not including the 20th byte. So starting with 20 should be, okay, so if I start at 20 and go to the end, that should be everything else after the pack. No, because there was more. Oh, shoot. It was like we have head signature. Okay, hold on. So we had our head signature. Okay, and then inside of here, so then we have pack. We have the version object count. So version and object counter is going to be in here, I think. So it was 20. So after the 20, okay, so if we do 1, 2, 3. So we know that this is 8 to get through here, including the new line. Then, so that's 8, 9, 12, 20. So starting from here, right at this lowercase o, that is where the first data is, maybe? So you have to start looking at that. And you're saying, Now it's bits 4 through 6. What are the maybe I want to get the first 4. Oh, it's bits. So maybe I want to get 1 byte and print that out. So the 20th byte. Everything after 20 should be the 302 entries. Okay, that does make sense. So we want to get the type would be next. So to get the type is maybe like this one byte. Now, I was attempting, okay, so we can't actually get the type from here. This is just like all part of the head for like what the metadata. If I want the actual refs or the commits or the objects or anything else. Okay, the next question is, am I getting the right one? Okay, commit hash that I'm looking for git commit. I want to debug that out. Or maybe it's like want. Okay, so we want 23F0 for BBB. And if we come back to CodeCrafters and we look at our logs, now this was for which one was this for? This was get sample 2. Okay, so let's switch over to get sample 2. So we can check to see that the commit is what we expect it to be. Okay, so let's put it into get sample 2. Get sample 2. You know what I could do? Because the locations this puts it in doesn't really matter, so I'll just keep putting it into get sample 3, but we're grabbing get sample 2. That won't confuse me later on at all. Okay, so I'm getting 7B8 BE0. And oh, they're looking for commit B52 5EF, which is not what we're going for. So it's the wrong commit. Now this one has 4 commits, and specifically we're looking for B521B, B521B, the first commit. So we're looking for the very first commit that we got. Now that actually still might be in, well, no. if I don't put a want for it, we're not going to get it. So we need to want this one at the very least. So we have to fix that first. So in our discover references, now I'm getting the first one here. I wonder if I want to get the last one. Is there a thing for last? There is a thing for last. Let's just unwrap you for right now. And that one is 7B8EB7, which is still this one. Huh. Now, looking at this, oh, we're only getting this one. Oh, that would certainly cause it. Yeah, so we're only able to request this one commit. Oh, and then from the other commits, we might be able to get. Okay, so theoretically, here's my like understanding now. We're gonna request the master branch, the commit for the master branch. And in doing so, we're going to get all the other commits, maybe? I hope. That would help a lot. So I guess we need to start walking through the rest of this thing. So we have our commit ref, which is really, this is a pack file. So I should probably rename you to be a pack file. This is really pack file. Okay, so we have our pack file coming to here. I am just debugging this, but I guess that's all. That's fine. We want to start at the 20. Okay, if we print out the 20th one, that should give us a single byte with the 8 bits that then tell us which type this is. Right, so we have our type bits, which is 3. Interesting. Okay, so we need to implement this now to read the type and then the size. So, okay, let's try recreating this. I will do it one little bit at a time, trying to understand how it works. I don't think I can write a test for this to begin with because I myself am like, I'm not really sure what I want. I can make it work against a test case, but I don't have the right, like, I don't know if I know how to do it. that's the problem. Let's go to test and we'll go up from here. So let's just have a function. I'm going to rename it the same. So in that case, this case, it is called read size and encoding. So oh, wait. Is it read size? I thought it was read size and type. Okay, I was looking at the wrong one. It's read type and size. Let's read type size. So we're gonna take in bytes. So we'll have our data, which is the bytes. In this case, can you be bytes? They might be able to be. I don't know exactly what type. Oh, it's probably going to be this object type that we return back. So the object type. All right, we'll throw a to do on here right away. And what do we want to do? We want to get the first, I think we just want to get the first byte off of here, right? And I wonder if I want this to be just a U8 that comes in. So we just grab the first one. Okay, so object type and uncompressed data pack size are stored in a size encoding variable length integer. Bits 4 through 6 store the type, and the remaining bits store the size. So, okay, the first one is we have our value, read size encoding. So that's to get the size. So get size. Then we have our object type, and they do this keep bits. Read the lower bits of value. Oh, that's lovely. And then we have size, keep bits. Okay. Value type bytes. That's actually here. Wait, where did that go? Nope. Okay, read type and size. Here we go. So read size encoding. Here's no, that's using it. Read size encoding. So we take in something. They're just going to put in a U size, that the actual size. So we start with the value 0, the number of bits of data read so far. Byte value, more bytes, read var int byte. Pass in a stream. Add in a data byte bits. Albert, hello. How are you doing today? Now, when we pass in read size encoding, you're doing great, but your computer's having a heat wave. Uh-oh, that doesn't sound good. Hopefully it cools down soon. Oh, you're trying some crypto mining software? Yeah, that can definitely overheat a lot of computers. Okay, read size encoding, and we're using that here. Okay, so we're passing in the pack file, but we're seek on that. Wait, does this? Is a mute pack file, but then you don't return anything, which means that you're returning, you're mutating the pack file. Oh, okay. Oh, you have a laptop? Oh, yeah, that's definitely going to push the laptop to the limits. I've never done crypto mining on my own. I've never really thought it was like worth the like I figured you'd never really get enough coins or whatever they're called. Zilby, you decided to hang out with us. Oh, you're looking way down. Okay, so what is seek? I feel like they're doing it very differently than I am. Okay, seek. They've taken a file with an offset, and okay, yeah, so we're doing with file handlers, and we're moving through it. So this would be the equivalent of writing the file out to disk and then opening it back up again. Is that how file works? Can I do something in memory for that? You weren't worried about the file stuff? Okay. So where's my... Oh, no. Where do you go? Okay, so we have read size encoding. I think the important part is working out the bit stuff that the pack documentation didn't really help with. Yeah, I think that is the case. If you pay for your electricity, then it is not profitable. But as I don't pay when I'm at school, you benefit around 20 to 30 cents per week. Oh, well, that's nice. And it is true. I do pay for my electricity. So it would probably hurt more than help. Okay, so the first thing is read the size encoding. Now, okay, and then you're doing value. It'll be okay. And then we're doing some fun, which I'm not like paying that much close attention to him, but I hear him like every once in a while doing weird things, and I have my monitor laptop in front of him, so I can't actually see. It sounds like he's like not happy with something touching his leg or something like that. So be okay? You could use it as space heater. Yeah, I think you definitely could. You'd probably also burn out your hardware too if you're just running it at that temperature all the time. Okay, so now that's for, oh, because like you need to keep bits. Okay, so we have the size to keep bits and the object type to keep bits. So we need to figure out which bits, and so the entire stream we now know is all of the bytes essentially, but zoomed through. So this would be starting at 20 to the end, right? So read type and data size, we know that this would be coming from what are you upset about? You're not upset. Let's do our object type. I forget what I called it. Read type and size. Okay. Read type and size. We are going to pass it the commit is the byte, so it's going to be the, oh, it's the pack file now. No, not the pack file. Yes? Yeah, no, it's commit. The commit. Really, this is like the pack file metadata, and then the commit is really the pack file. Okay, so I want commit, and I want 20 to the end. Which you are, can I actually get a slice off of you? So return a slice to self for the provided range. I want 20 to the end. And that gives me, I guess, like full bytes. I guess it creates a clone of the bytes. That's fine. Okay, so we now know that we're starting on the 20th one. So we want to get, if we want to figure out the object type, we need to find whatever this value is, which is the read size encoding. So read size encoding. Here, we're going to read var int byte with the stream to get the byte value and then more bytes. Is that just get 1 byte? Read byte stream. Okay. I'm guessing that gives me the first one. Where's read bytes? Don't see read bytes. There it is. Okay, so read bytes takes in our bytes and takes in a const n u size. Okay, interesting. I've never seen a const n be used inside of a function signature before. and we're going to turn a U8. Okay, the number of bytes. Okay, so okay, we create the number of byte there, and then read exact. Okay, so basically we just want read exactly that many bytes. So if I just want the first byte, so let like our first byte, that will be data. Now, can I get a first, like first? I don't know if this is a good idea or not. We're gonna find out. That gives us our a U8, which I believe is exactly what we're looking for here. So let's see, what was this called again? This was read type and size. Okay, so we just want, okay, now the size and coding. We get the first, oh, read variant byte. So we get the first byte. Oh, ad break started already. I didn't even notice that coming. Sorry everybody for having that hit. I don't know if it's gonna hit all of you. Twitch ads are interesting. But first, like, stretch break, I suppose. We can do a little bit of Zilby Pet too. Zilby, you okay? I can hear him purring just a little bit. Okay, back to this. So we got the read byte, so we got our byte. We want the byte and variant continue flag. And the variant continue flag is this one bit shift left by 7. Okay, so to get the variant encoding bits, read 7 bits of data and a flag indicating whether there are more. Okay. And then this is going to give us, oh, a U8 and a Boolean. So the value, whatever that means, and then if there are more bytes or not. So we should probably just do this. I'm thinking we should create a folder and re-implement what we have here in this article. Since this is like less of our code that we're inventing and more of like re-implementing somebody else's code. And that way we can also give proper credit for this too. So I am gonna go ahead and do that. We're gonna create, because that way I can put all that stuff, just throw it into one thing. One file. So let's get sample 3. Okay, here we go. Let's go into source. What do we want to put in here? Let's touch. This is process pack file. There are not 3 good ways to decode a var int. There are not 3 good ways? As in there's more or less? I guess let's go to, oh, do I not have a library? What do we have in here? We have, oh yeah, we do have a library. Oh, I probably did B. Pubmod, this is process. Oh, you can't find it? Why can't you find it? You're in source, so I did that correctly. Less. Code ownership can't really apply on the decoding of a variant. Code ownership can't really apply on the decoding of a what? I don't know what you mean by code ownership. Like that the person's like, oh, this, like, I own this code type thing. I just more of, I want to make sure I give credit for who I'm taking this from. So that way, if anybody else wants to look at this, like, we can take a look at that. They can like go and take a look at this yourself. All right, so borrowing, because I'm borrowing because I'm not mutating it. See, implemented using as a reference. All right. So a few different things here. We want to, we have our read type and size, and so we realize that we need to do this read variant byte first, and then okay, so then we get the, okay, so we do our function read variant byte, right? Yeah, read variant byte. I'm gonna put this over here so I can reference it. Oh, you just read the first entry using some of that code. Nice, excellent. Well, then that lets us know that it's working. Whenever I move this to my other screen, it like completely changes where I am in the location of the window, which always has bothered me when I'm like moving things to like different resolution displays. It's like the operating system is still not good at like retaining where I'm zoomed, like where I'm scrolled, which really sucks. I don't know what to do about that. Okay, read variant byte. There we go. So read variant byte. So we're gonna take in our bytes. It's gonna be a bytes. And we're gonna return a result. Also, I really wish, this is more of just a negative on dev too. It has such a big advertisement thing on the right. I guess I can like full screen just that code, but that kind of sucks that I have to go back and forth with that. Okay, so I want to use anyhow result, and we're going to return from here a tuple of U8 and a Boolean. Okay, so first off, we get the first byte. So our first byte is going to be equal to bytes first. You can expect missing first. Okay, so we get the first byte out of here. And then we get the, okay, so the value the value is going to be this byte. So it's going to be our first byte. And that it's ones line up? No, that any of its ones line up, I think. Is that how it works? And not. Now this varint continue flag. So we need to create, we're going to have a const varint continue flag. It's going to be U8 1. That's bit shifted left by varint encoding bits. It's also U8 and equal to 7. So the write bits, so a byte is made up of 8 bits. And so we have, when looking at this from a binary point of view, we have 8 numbers next to each other. You'd stick with using the read trait. Can I do the read trait? Is that... Well, hold on. None of this is using the read trait. This is all still not just using whatever this is. So do that. Then you bit shift left by varint encoding bits. So then we're going to do and not varint continue flag. And then we have more bytes. Okay, so that more bytes. This is going to be our first byte, and varint continue flag is not equal to 0. Okay. And then we return okay, and our value, and then more bytes. All right, so that's read the variant byte. Next we have the read size encoding. So we have our pub function read. Let's see. Amon Terome, hello. How are you doing today? What's the name of my theme? This theme. Is Adwaita Dark. If you pass the whole thing in each time, it won't know where the new position should be. So then the read thing is off of a file. So we need to save it as a file first to deal with that. Wrap the byte slice in an IO cursor. Ooh, I've never done that before. Okay, let's try that. Now we haven't gotten to anything where we were doing that with, right? Oh, except you're talking about read bytes here. We have like read bytes and then you get the stream, which gets me the first byte, but it's whatever has been seeked to wherever we are there. Okay, so then this would be not bytes, but something that implements read. Okay, that makes sense. Now does bytes implement that? What was it called? It's I think like seek. I don't think that bytes implements it, does it? So I would have to, yeah, would have to take the bytes, wrap it in an IO cursor. Now there's cursor used with in-memory buffers, anything implementing as ref U8 to allow them to implement. Okay. Oh, yes, that's pretty simple. We may want to write bytes to a file in our, oh wait, this is just examples now. Okay, cool. So where would we do that? We would do that in clone. Okay, so we get the pack file information, and so at this point in time we now need our cursor. So we let mute. This is going to be our cursed commits. Yeah, so like cursed pack file. This is a terrible name. Cursor new, and then we want this to be our commit of 20 to the end. Oh, size for values of type U8 cannot be known. Okay, so I have to reference you. Bar move value commit. Okay, so we have to clone the commit. No. Okay, so I can't. Oh, do I have to turn into, maybe I have to turn into a vector. Don't pass it in a pack file above. Oh, yeah, I'm let's see, pack file. Are you taking the new bytes? Oh, wasn't it getting the slice from this? I was getting the slice from this. And I could really just do 0 through like 20. 21. Now, I think though the problem though is that I can't get commit. Okay, that does work. So now we have our cursor, which is over the U8. Okay, nice. I wonder if I can also give it. Yeah, I did give it away, didn't I? Okay, so we now have this cursor that implements read. So that's the reason why you're all implementing. So, okay, so I could implement this as a cursor like this. I could just say, I want you to be a cursor of a reference of U8, but I could also do the generic R, which also works. So if I just do like mute R, and this one is going to be, we want to read bytes. Oh, but we can't do that. So we have to do bytes. I want to seek, get. I have to go find read bytes. Read bytes takes in the reader and then a const and u size. Okay, no, take in the stream. Take in the stream. We want to get however many we're going for, which in this case, we're always going for 1, I think. Which is not defined here. That's fun. Okay, read exact. That's what we're looking for. So read exact. So read exact, and I want 1, I think. Oh, and I have a result already, right? Okay, so that gives me... Oh, but that doesn't give me this thing. Oh, read the exact number of bytes required to fill a buffer. Oh, I have to pass it in a buffer. Oh, okay. So yeah, I need that are bytes. Shoot. This is what do we want to call this? This is the commit bytes. This is the pack file. So pack file stream reader. I want to then get our bytes. There's really 1 byte. I'm taking the pack file reader, read exact byte. Oh, and that's it. Oh, And then I need to tell, why did I keep on doing that? I don't know why I'm doing that. So byte, it's gonna be equal to that one. It's a U8, one of them. And then we do pack file reader like that. Okay. That gives us our byte. So I don't need to do that anymore. So then we have byte and you. Byte and you. Okay, then you're happy. All right. So then we need to find where it was. Let's see. Koovie Man, hello. How are you doing today? Thank you so much for the raid. How's your stream? And also Raiders, hello. How are you all? Hello, Nerdsol. You forgot how to code. I mean, I do that all the time. I mean, that sounds like a Monday too, right? A Monday problem? Davey is here. Hello. How are you doing today? What are you working on today? And hopefully you remember to code by the end of the stream. Oh, should do this the other way around. Like that. you're working on your game, but you did just a very tiny couple lines of code. There's been times that we've done that here too. Yeah, it's a thing, right? But hopefully things are working out well. Thank you again for the raid. For everybody who's come along, what we're working on here is a build Git from scratch. I guess like, no, it's not Git from scratch. It's build your own Git. And then we're using Rust for that. And we're, as the guide for this is CodeCrafters. CodeCrafters is a tool. It's a subscription tool that you can use that basically does a bunch of scrimmages, like tests, like challenges, essentially. And then the Git one is what we're going after. And full disclosure, they did give me a free account and a code that can be used to purchase it, which then I get, it helps fund the stream. So if you're interested in that, let me know, and we have a command to get that code, get that link. But yeah, we're currently working through this. We're at the very last stage of the entire project, which is, of course, the hardest one, which is cloning a repo from GitHub. So currently what we're trying to do is re-implement what we found here in this dev2 article, which is reading through what is called a pack file. And we did a request. So it's a 1-2 punch thing here. We did our initial request to GitHub and we found this information, and we figure out, okay, this is the commit of the branch that we want to get. And so we take this and we pass it into ref discovery, and we get this back. And so we need to read through this thing here to figure out what it is we need to, well, all the commits. Like there's all the commits, all the files, all the other stuff is in here. And so that's what we're trying to get out. And that's what these things are going to help us do. At least we're hoping to. We have some, as Sitsu let us know, that this does work. So we're not going down a completely terrible path here. It's just you know, time consuming, that kind of thing. So we just implemented read variant byte, but I don't really know if it's gonna work the way we want it to. I wonder if we can test this. Okay, so read 1 byte and then give us back the value and more bytes. So if we pass into here, so let's get rid of you. You're upset. Oh, okay. So here, let's can I find type R in the scope? Okay, so I need to, shouldn't it know that this is a generic? I think, okay, so we have to say that, is it something like that, where you have R and then your implement read, and then expected value found built-in type U8. That's, oh, right, I want you to be the type. So we have that, and then you're going to be equal to an empty thing. Do I have to initialize you? I guess we do. And then we'll, oh, how do we fill you? Because if I don't set you to be something, you're gonna yell at me because you're mismatched types. How do you do this? And read bytes. Okay, yeah, you are initializing it to 0. So okay, so this is initializing it. Oh, interesting. Okay. So this is 0, and there's only one of them. and then we read exact to fill up this buffer, and then we return it. So then we read exact to fill up this buffer, which is interesting that it's, okay, so it's zeros and size, okay. So we get our, then we get the byte out, which is read exact to the byte. Now this is a vector. Okay, so then I need our, technically this would be bytes, right? So then I want that byte. So then destructure that out. Then we're gonna do some bit shifting fun. Okay. They're gonna do some bit shifting fun and then return the value of this byte and then whether or not there are more bytes that we need to get. So we want to pass in the first part of this, which I think we've already done. So read variant byte from here. So we have our cursor, which is our cursed pack file, because, you know, it's a cursor, right? A cursor over the pack file. And we're going to hand it that exact same thing right there. So let's do let variant byte equals read variant byte. We're going to pass it in the R, which in this case is the cursed pack file. You need to be a mutable reference. Okay, so cursed pack file. That question mark U. That gives us the U8 here in a Boolean. So if I just debug U, we're gonna have variant byte. So we want variant byte. Here we'll just give ownership to you. You're all good. All right, so if we now move over and run this. Okay, so our variant byte, we have 29 and true, there are more. Great. Okay. Now we have read size encoding. Okay, so in loop. Oh, so that's why we do read more bytes and then read variant byte with the next thing, because we are doing something. We get our value. Okay, so we convert the value to usize. Bit shift left the length, which is however many bits of data we've. Does the length ever increase? Oh, the length increases here. Okay. Oh, by the variant encoding bits, which is 7, because the one on the very left is the one that tells us if there's more. Okay, so then, all right. Next up. So we have pub function, read size, encoding. All right, so we know we're going to continue with the generic, so we're going to have a R, which implements read. We're going to take in our, now this is the same stream, but it's our pack file reader, really. We're going to return a result. And in this case, we want to return in, we're going to return the value here, which is the size encoding. And that is a, can you see this? Oh, it's kind of below Zilby, isn't it? which is just going to be a usize. Okay. Okay, so what are we going to do in here? So we set our value to 0, and we're going to or equals. Okay, so if they're is this if they're equal to 1 in any of the same positions? I don't remember my bit stuff. It's been forever since we did this with the ECS course, or the various. We implemented that like 3 times, and I've now forgotten everything about like the bit stuff. Okay, so that's gonna. Oh no, this is if you're not equal to 0 and you are equal to 0 and you're equal to 1, set it to 1. I think that's what it is, right? So we're updating value. So we're going to start it with 0, 0, 0, 0, 8 zeros, essentially, like, you know, one byte of 0. So if we have our value, but you need to be immutable. And then we have our length. So this is the number of bits of data read so far, which we're going to use to determine. Oh, no, we're going to use this for shifting and making sure that we don't read the same bytes over and over and over again. So okay, so if we start into those things, now we're going to start our infinite loop, and we're going to read in a variant byte, which is going to give us this value, and then whether or not there are more bytes. So we have a byte value, and we have more bytes. Read variant byte, and we're going to pass it in the pack file reader. Which reads in 1 byte, which reads in 1 byte from this pack file reader. Okay. We want to get, okay, so then our value is going to be or equals, okay, so then not or equals, it's this is the if the ones don't line up, like set them. It's like set the ones, I think. We want the byte value, so we want to convert the byte value to be a usize. We need this to all happen together in one thing, and then bit shift it left by the length. So this is going to be our byte value as a usize, and then bit shift this length by the length. If there are not any more bytes, we're done and we return. Otherwise, we continue through. So if there are not more bytes, so if you're false, then we're going to return okay and the value. Otherwise, we're going to increment the length. So length plus equals to the variant encoding bits, which is the 7 of them, because the first bit is the are there more bits or not. Okay. That gets us to this U, and then we can return out of U. Oh, we don't return if you, it feels like it doesn't have everything here, right? Because the compiler won't let me do this. Will it? Oh, it will let me do that because this is an infinite loop. So yeah, either, interesting, either we're going to return this or we're going to stay in a loop forever. That sounds perfectly fine. Nothing can possibly go wrong here. Okay, so read size encoding. So let's come back to you. So we got our variant byte, but I don't really care about this anymore. So now we're gonna do let our size encoding. And this is gonna be our read size encoding. We're gonna pass it in the cursed pec file, which is a mutable reference to it. Cursed pec file, and then we do that, and then we want to debug the size encoding is the size encoding. Okay. Spike Spaz, hello. How are you doing today? I don't care about you anymore. I don't know what you're talking about. I'm confused. Also, it's the first time chatting here. All right, let's try this again. So our size encoding is 1821. Now I don't know if that's good or bad, but it certainly is a number and it's not a crash. So that's a good sign, right? So that's great. Let's find out. Let's go back down to where we, okay, read type and size. So we are going to, oh, nonsense taken out of context from a statement of yours. Okay, got it. It shows you the mindset I'm in, that like you can tell me a joke based upon something I said and I just don't get it because I hyper focused on this a little bit too much. So sorry. Also, hello again. Anshul, hello. How are you doing today? CodeCrafters looks really amazing. I do like it a lot. The only negative to it is that it is really expensive. So it's one of those things where if you have a education budget, if you know at a company you're working at, that would be, to me, that would be the best use of it. Okay, we can finally do, I believe. No, well, we can kind of start with this. We're missing keep bits. Okay, so read type and size. So we can start with this now. So pub function, read type and size. So we've taken our reader. So this is going to be our pack file reader. We're going to return a result with, this is going to be a tuple of a U8 and a size. Okay. We'll start with this, a U8 and a U size, right? Yeah, a U8 and a U size. And we're going to throw a to-do in here because we're going to run into trouble. We first find the size encoding. So now they're using the very helpful value name here. So let value equals, so read size encoding. We have to pass in the pack file reader. Then we grab U. So that's our U size there. And then we have our object type, which we want the keep bits. Now we have to go find what keep bits is, which is literally right above it if I had looked up. Perfect. So we have a pub function, keep bits. Now we're going to take in a value, read the lower bits of value. Okay, so that means the bottom 7. So we're ignoring the first one in there. Okay, so value is a usize, and then we want bits, which is a u8, which really this should be a bit, right? Like not a bits, but okay. We're gonna return a usize, and now we want, okay, so this is just a one-liner here. We're gonna take our value, and we're going to and, so wherever the ones line up. And then in here we have a 1 bit shifted left by the bits, then -1, which I can't remember what that does, but okay. We're just gonna blindly read it. Hope that it works the way we want it to. And we're gonna get our object type is now going to be into keep the bits. So we want to keep the right. Okay, now we have to tell it which bits to keep, right? Because that's where this bits here is. Wherever the ones are is the ones we're keeping. So we have our the value that we're passing in, which is that size, okay. And then type byte size bits, which is a U8, unsurprising. A var-int encoding bits minus type bits. Okay, and so we see like the type bits are the final 3, I think, of a byte. And then the var-int encoding bits, we already have in here, which is a 7. So, all right, so basically it's the last 4, but then there's some other weird stuff that might be going on with this. So, all right, let's add these in. So const, we have our type bits, which is U8. It's a 3. And this is going to be our var-int encoding bits minus the type bits. Was there anything else? No. Okay. So you're happy now. So then down here, we're going to say for the keep bits, our value that we got, which was the read size encoding, and then our type byte size bits. Or which is where the zeros match up. The and is where the ones match up, and the or is the pipe. It's not an or. Is it an or? Oh, I don't remember anymore. Then it's our value bit shift right by the var-int encoding bits. Bit shift left by the type byte size bits. And that's it for, that gives us our size. And then we're going to return an OK, object type, and then the size, which, that was just the object type. Oh, I did this wrong. Okay, hold on. So object type, value. Oh, wow, I did this very wrong. Let's do this again. Okay, so in keep bits, for object, this one here, we pass in our value bit shift right by type byte size. Okay, so our value bit shift right by type byte size, bits, and then also our type bits. And then we make sure that that is recast as a lossy cast as a U8. And then now we're going to get the size. And now we're going to keep bits, and we're going to have our value just straight up as it is. And then also our type. Oh, interesting. Okay, so keep bits itself. So we do the type bytes like that. And then this entire thing, we then like that to then say keep the zeros, or set the zeros if the other one's zero. I can't. It's been too long. We have our value, bit shift right by variant encoding bits, bit shift left by type byte size bits, and that's it there. And now we can return, okay, object type size. Interesting. Oh, you need to be a tuple. Okay, there we go. Now you're happy. So now I can read type and size of the first object here. So read type and size. You take in just the data. Wait. Oh, it's the wrong one. Ooh. I don't want you. Okay, read type and size. You take in the pack file reader, which is the cursed. Oh wait, you're fine there. Object type, you don't care about that. Okay, so now we should get object type. Which you're going to be a tuple of the U8 and the size. Okay. All right. No errors. Let's run this. Our object type is 1 and 237. Bean Pranjal or Pranhal, hello. How are you doing today? What a great time when you're thinking of building your own Git today. Nice, excellent. We're currently on the cloning part of Git, which is the hardest part. Is like just getting the information from GitHub, and then after that it should be relatively simple once we have the stuff. Okay, that looks right. Thank you, Isitsu. Okay, now type 1. Now, if I remember correctly, this was actually given to us somewhere in here was the different types. And I don't remember off the top of my head which documentation file that was. But I want to say that type 1 was a commit. It has been a week, though. And it's a Monday. I don't think I can have like a type. Let's see. How about a pack file? Maybe get upload pack? No. Oh, that's cool. You actually read a high-level guide from Git.let.js that implementation is in JS. Oh, nice. Pack format. Okay, that's where it is. Pack format. Go. Right, this is where it was. Okay, so yes, object types are git commit type 1. Excellent. Okay. Now, so if I want to turn this into an enum of what we're looking for, this is where now we have our types. So we have just a pub enum. Actually, we have this in the other file, don't we? Object type. Okay, so we want to grab all of you. Okay, so we have our object type. We have our commit unknown. Okay, so we do a new and then we hand it. Okay, so in this case, we're going to hand it the object type, which is a U8. So, which is a U8. I want to match an object type. So if you're 1, you're going to get a self commit. Otherwise, for everything else, you're going to get an unknown. All right. Who wants to bet that I'm going to forget that I didn't implement the other ones and it's going to bite me in the butt later because I completely think that this is fully set up. Okay, so then object type. So instead of a U8 here, we're going to make this an object type. And so object type. Let's do this shadow object type here equal to object type new from object type. Okay, that should make you a lot happier. And then we'll just derive debug. Which means that if we rerun this now, private type, object type, it's private? It is private. Okay, so now we can see object type is commit. So instead of having to track numbers for that, we actually have what this is, which is great. Back to you. Okay, object type, kit bits. Okay, so we did all that stuff. So that is read, that was read type and size. Okay, and then that's the, so we want to put the size in the object type. That could be interesting. And sort of have it all together. That might be nice. Just to store, yeah, let's do that. So let's have commit is then going to be a usize. So we have our size, which is a usize. So commit, throw in a size in there like that. So then, actually, This will make this a little bit easier. Instead of a tuple that we're returning, we're just going to return the object type. That's it. So object type, new object type and size, come in here. And so if we rerun you, now we can see we have our object type is commit, and at 700, where am I getting that number from? 237 bits. Oh, ad break started. Do you have the decompress implementation? Maybe. And ad break just started with Twitch, so I'm gonna go ahead and take myself a quick break because it's already been 2 hours, which doesn't feel like it's been that. This stream feels like it goes so fast. I'm gonna go ahead and refill, get something more to drink, and I will be back in a couple minutes. And in the meantime, you can watch Zilby. There's my cat Large. Yeah, you don't even see that. And where's my break time? All right, I will be right back. Oh, Zilby moved in. Okay. Well, that's a thing. He moved onto my chair. So hold on, let me switch back to you. Oh, you can almost see him on my chair when he's sitting up like this. Okay, Zilby. Well, I guess that means you get the chair. And I get to switch to standing desk mode. All right, and then hey, don't do that on my chair. You can lay on here, but don't clot. All right. So no more looking at Zilby, unfortunately. When he's on the chair behind me, I don't really have a good camera angle for him. But he's doing his appropriate management thing and telling me that I need to switch to standing mode. So here we go. Now, do I have, okay, so now it's time to decompress, isn't it? And we want to check out what that is, don't we? That being said, bits 4 through 6 store the type, and the remaining bits store the size. Oh wait, so is this all one byte stores all that information? I think so, right? So then starting at the next byte, how am I making the pack file to push to server? I'm not, as far as I know, we're not implementing a push for GitHub, just a clone, just a pull. So the challenge website that I'm using doesn't have a push set up for it. So I don't, we're not going to be making the pack file. You had a problem with decompress being too greedy, and you just found the exact same issue on Stack Overflow from almost 9 years ago about a git clone in Rust. Oh no. Oh, the decompress being too greedy. Ooh. Interesting. Well, I bet we're gonna run into the exact same problem then. Okay, so now we have the size. Okay, so we have the object type. And I just wanted to get the first one here, right? Because we know we have like 302 objects total. So we're gonna have to be doing this a bunch of times. But just for the first one, we get the object type and we print that out. So that gives us this object type, a commit, and there's 237 bytes in the commit. So I want to take those 237 bytes and we're going to slice those off, right? So let's let compressed, it's going to be equal to our, not object type, I guess the cursed pack file. Now, I need to read through it by 1, right? So we skip by 1. How do I've not really used read very much. These other things, were we seeking at all? Oh, it's seek by 1, right? Yeah. Okay, so you do read. Now, when I read in the bytes, okay, after calling read type and size, it should be at the start. Okay. All right, so then I just want to read. Oh, okay, that's good. Of the compressed data. Okay, nice. So then, where am I? We have our size. So let's now we have our compressed bytes, and this is going to be an array of zeros that we have be our object type dot zero. Oh, because the other one might not have it. Okay, hold on. I need to make sure that either every single one of them have to implement usize on this, which kind of makes sense. Let's just do that here because we're passing in size anyways. So now that should work now. Shouldn't you work? Attempt to use a non-constant value in a... Oh, you have to be a constant? Oh, okay. Well, then I guess you have to be a vector. I can't... Okay, so you have to be a const. I don't have it except at read time, so you can't do that. So we're gonna have to use you as a vector. As a vector, you're gonna store U8s. And then can I set a vec of U8? No, a vec. How do I... Hold on. What have I... Okay, there we go. Turbofish syntax, new. Can I also set you... Oh, capacity. No, that returns. Can I set the capacity? I've done that before, haven't I? Reserve. Reserves capacity for at least additional more elements with capacity. Oh, that's what it is. Okay. New. Oh, it's not a new. It's just there it is. With capacity, object type 0. No field, 0 on object type. Fine. Okay, so then here we'll go back to this, and I'll just make you an option. So we're just gonna say pub function get size. And we'll just do match on self. If we have a self commit with the size, we return some size. Otherwise, if you're anything else, we return a none. Oh, you're a... Okay, so you get there, that's fine. So you have used, and we just do get size. And we'll unwrap you, because we know you're safe. Okay, why are you upset? Borrow moved. Oh, object type. I gave object type to debug. Yeah, I don't want to do that. Okay, so now we have our compressed bytes. Okay, so now decompress. Inner utilities. we have a decompress here. So we take in a bytes, we create our decoder, we get a result, we read to the end, and we get a result back. So I should be able to use that decompress here. So decompressed bytes is now going to be equal to decompress, pass in the compressed bytes. Yeah, I'm just using Flate2. zlib Flate2. That. And okay, so now we have decompressed bytes. Now I should be able to debug out the decompressed bytes. No? Oh, wait. I do need this to be... Okay, hold on. Because you're gonna be empty right now. So I need to, before I do this, we're gonna have our cursed pack file. And we need to read exact. Read exact. And we pass in the compressed bytes. Okay. So now I'm going to pass in everything. Okay, now this should work. Result, corrupt deflate stream. Okay, so it still can't get that. Still no? What's the no? Because I filled up the compressed bytes. It's now been filled, right? Yeah, so I read exact, it fills this up from the size, and then I attempt to decompress it, but obviously that fails. So the compressed size is not the same as the decompressed size bytes. Wait, what? So the size is the decompressed size and not the compressed size? That doesn't make any sense. How would we know how many bytes are compressed if it's trying to tell us how big it's going to be after it decompresses? Do we have to loop through it until we find like a null or something? Well, the decoder can't figure it out because you're passing multiple things to do. So I'm not really sure how that works. Like we have to pass in only the compressed bytes, and like not bytes that are like a mixture of compressed and not compressed. So like the entire thing isn't compressed, right? Like it's multiple compressed things together. I thought that's what we have. Or is it everything else, like all the way from like this to the end? I guess it could be everything else is compressed, which means I want to pass in all the rest of this stuff. So I don't have width capacity. Okay, so I don't need this. What I guess what I need to do is I need to get all the bytes out, but at the right place. So I need until the end, like we need read to end essentially at that point in time. Do I have that as an ability? So instead of read exact, is there like read to end? Read to end. There we go. Read to end. I don't have a width capacity on. We just change this to new. You're going to figure that out. So I read to end and pass that in. Okay, how about you? Oh no! It's Hitsu, what happened? Unfortunately, bot did hurt you. Oh, what is paste RS? I've not used paste RS before, but I trust you. Okay, so we have position, cursor, position. Okay, so we have contents, vec with capacity size. Our decoder. Oh, interesting. So that's a different way of doing it. Okay, so we're going to read. So decode until we've filled out how many we have. Okay. Okay, so I need a different type of decoder. I need like a decoder. I need to decode a certain amount then at that point in time. The total in because the decoder puts the cursor at the end once it finishes. Okay. Oh, right. Total in. We figured out how many we got, how much we got, and then we seek from, oh, start position plus count. Okay. Interesting. Okay, I'm going to put this over on the left, and we're going to create... we could just do this right here. This will be fine. This will be fine. Okay, so let's reset. All right, so we have our object type, which includes the size. So we have to get where we are right now. We have to keep where we are right now. So that's our like our current first pack file position. So our current pack file, we want our current position. Current position, thank you. Okay, then we want contents. Okay, so we create a new vector. So this is going to be let mute. This is going to be our decompressed object. Like we know right now it's a commit, but it's really, we don't know, it could be, it's whatever object. So decompressed object. And this is going to be a brand new vector. We're going to do a width capacity, and this is going to be our object type get size unwrap. So that gives us a new vector, which right now it doesn't know what that is, but it'll figure it out. We create our new decoder. Which is going to be which one was it? Was it a buff read or a read? I think it was a... literally exactly the same documentation except that. Okay, so just read. New, and then we put in the cursor, which is going to be the cursed pack file. Okay, that gives us our zlib decoder. Crimson X Mana, hello. How are you doing today? Buff read is for handling line by line. It probably is. Although in the I wonder what the other one. What's the other one we're using? Decompress. Yeah, buff read. Okay, so we were using the buff. We were using the buffer read as opposed to the read. I think. Let's see. This R. Oh, but this one implements R read too. Okay, so I don't know. I don't know what the real difference is. Because I don't think we were handling line by line before with that. Oh, when we were using read. Okay, so never mind. I've never used buff read. So I'm not exactly sure what it is for. Okay. So we have our decoder now, and then I want to decoder read to end, and we're going to pass in. Okay, so now we're going to do decoder. We're going to read to end. And we're going to pass in the mutable decompressed object. And then we have to find out how many we did. So this is going to be our decoder, how many we got, and then we want to update our cursed pack file. So our cursed pack file, we're going to seek why can't I do seek? What are you cursor? Shouldn't I let you seek this? Oh, there it is. Okay, so seek, and then we're gonna seek from start. We have our position, which is the okay, that position plus the count. Question mark that. Okay, and then we're ready for the next one, so we can then throw this into a loop. Okay, I need the seek trait. I keep on expecting that Rust Analyzer is like better, because like I thought that I read in the This Week in Rust that Rust Analyzer updated to read through the different, it was features, wasn't it? Like, so sometimes it's pretty good at figuring out what traits need to go in, like show me the options and then just auto bring in the trait. And then sometimes it's not very good at that. I don't really get why it sometimes doesn't find it and why it does. Because like if I understood when it wasn't happening, maybe I can like cause it to happen more often and like be better. No reason to apologize, Crimson. It's like we're all parrying / mobbing here, hanging out. It's like we're on a couch in front of like a big TV, all parrying on, some of us are working on our own projects, some of us are just sort of hanging out, and some of us are all sort of like staring at the big monitor, figuring, and I just happen to be the one with the keyboard. But other than that, we're all working on this together. Okay, and now, so this is, so this decoded, so now we have our decompressed object. So now I theoretically can debug decompressed and pass in the decompressed object. This may be a terrible idea to try to print out because I wouldn't be surprised if there's binary stuff in here. So this might crash in the debug. And I might have to write that to a file. Okay, so the loop got to index 187 until you reach type 7, which you apparently need to handle differently. Oh, fun! Okay, so the first one, though, this should be fine then. Okay, there we go. So here's the bytes, the decompressed bytes that we got, which is this. This is more than 40. Okay, so let's try the string from UTF and see what we got in there. Oh, you need to be owned. Okay, fine. I'll give you ownership. Just this once. Oh, cool. Okay, so we have, what are you? Here's our string from UTF-8. Okay, so we have our tree. Okay, so the first object is a tree. Oh, wait, no, wait. That's what you got? Is this supposed to be a commit, or is this actually, the commit has the, okay, right, because the commit has the tree in it. Because the commit is made up of many other things. So we have a tree, and the tree is the folder and file structure of everything. So here's the tree. And then parent. Okay, so we have our tree, parent, author, committer, and then update, then what the message they did, which was update content. Great. Now I bet that we can go find this commit where they wrote in the message update content. There it is. Update content by Rohit Paul K. So Rohit Paul K. And if we come in here and we take a look, then we have, okay, this is all the stuff in here, which is gonna be fun. So the first object in here is a tree. Parent at top right too. Oh, parent 65262 65262. Okay, here we go. So one parent. And if we look at that, oh, so now we can get, yeah, this is a different commit based upon that. So I wonder, yeah, you wondered why the count was so high. Oh, so we're gonna have to keep track of the commits that we found, and then, oh, interesting. So if I keep on doing this over, and eventually I'm going to get to know more parents, am I? Yes, then this is it. This is now B52-1B591, which if we look at what we're looking for, B52, yeah. So currently CodeCrafters is running our command to do the git clone. It's seeding into the directory. and then it's trying to run git cat file on the commit, which of course we don't have that commit written out. So obviously that's a problem. But we can do that. We can do it. So this is our issue. Okay. Now, if I was just trying to like cheat my way through this, I would probably just ignore everything that's not a commit. That being said, each commit has the other commits. I wonder if it's sort of like a log. We're sort of figuring out what these look like. Yeah, just write everything that should be there. But I think that's probably the easiest way for us to do it, right? Just write it all out there. Now, so if I take this thing here, which is our tree. Now, if I just write you, if I just pass you to write tree, will that work? Now we have a write tree here. Oh, but the problem with write tree. Wait, can I just save file? Can I just throw this straight into save file at that point in time? Which compresses it and throw it. Okay, so maybe. So here, so we have our compressed string we have our decompressed object. Now I gave it ownership of it, so fine. Let's try save to disk. And I want to save the decompressed object to disk. Do you return anything? You return the hash. Okay, so saved to disk. Pass in that hash. Oh, which then I want to encode into hex. Decode hex? I thought I could encode hex and yeah, okay, so encode the hex, strict representing itself into the result, lowercase letters are used. Okay, that should be fine. I'm doing this off of a vec of U8. Why type annotations needed? Multiple impulse from this. Also, Skimmus, hello. How are you doing today? And Lloyd, raiding with a party 4. Welcome, Lloyd. How are you doing today? How's your stream? And what were you working on? I need an iterator? I could swear we've done this one before. That is the hat. Okay, so the other thing though is I could just do hex encode and hand it the hash like that. And that works. So trying to use the method with the trait that was added onto vectors didn't work, but this does. Yeah, no errors. So let's run this. And now in get sample 3. Okay, so down here, I'm in get sample 3. Am I actually in get sample 3? Because I keep on deleting and recreating this this exact same name of a directory, and I guess like as long as I don't freak it out too much, it's fine. So we have nothing in here right now. Oh, maybe I'm not fine. Yeah, okay, so we have a .get. And if we cd into .get, cd into objects, we have no objects. Okay, we're going to head over here. We're going to run this again. And we just committed, it looks like, oh, no, we had a problem. No such file or directory. Oh. Huh. I think I'm not writing it to the correct location. I'm trying to write it to the target here, but I'm writing it to my own, which is not where I wanted to put it. Maybe I was missing the hex to hex. Oh, I was probably. I keep on hoping that Rust Analyzer is going to add that trait for me, because sometimes it does, but obviously sometimes it doesn't. That is not the right command. Let's see. So we have our hash. I panicked at main unwrap, no such file or directory. Oh, because wait, did I run this? I ran this command in source. That's our problem. I need to run it out here. Okay, so there's a few problems that we have here. Let's do this one first, and now you should work. Okay, so here's the hash that we saved. The problem, of course, being that it didn't save in here. It saved in here. So if we go into get objects, this is going to save in C9. And we have 67E63. This is where it saved it. It saved it in my own Git directory as opposed to the one we're going to, because that's where Save to Disk knows to do it. Yeah, you get the same problem as well. It got better with some updates. Yeah, it does seem to be slightly better than it used to be, but only slightly. I am hoping that with time, Rust Analyzer and the LSPs get really good at this, which will be amazing. And they probably will. The LSPs have been getting pretty, like, if we like step back a year or two, they're so much better than they used to be. Okay, now if I do a get cat file of C9 this, is it cat file? Only 2 arguments allowed. Oh, it was like P, right? Get file dash P. Or no, this is a tree. So get ls tree C9 header too long. Okay, so it is not a proper tree file on its own. We need to do something to it before we store it and save it. So that's unfortunate. You think it was because there was a mismatch between your updated REST analyzer and outdated packages through Packer? I mean, I suppose that could be. Oh, your regression where it just wasn't doing it at all. Yeah, I've had weird regression times where like things just don't seem to work at all, and other times where I need to like restart the LSP constantly to get it to work. So I don't know. I feel that we're in a pretty like a period of fast change, and like if everything's like versions aren't exactly the right combination, then things don't work the way you expect them to, which is too bad. But also, you know, we're on the bleeding edge, right? If not bleeding edge, we're on an edge of some kind. Okay, so we know that this was a tree of some kind, right? Well, yeah, we know it was a tree. No, it's a commit. Is there a way from is there a command to like read the commit? Or no, that was cat file. Cat file should be able to read it. Oh, you know what? We have the pigsy command. Pigsy, and we're going to read in C9, whatever this is. Pass in here. Okay, so here we have this. So this looks fine. Now, whether or not this really is... Okay, so we have tree of this. Now, if I take you... I wonder... I'm a little bit concerned that this isn't what I think it is. This is a commit. When I commit, I get a hash back, and then can I ls tree, can I cat file the hash? So hold on, let's try that. Let's do a git log. Okay, here's a commit that I did most recently. Can I get cat file -p that? I can. Okay, and that does give me... Yes, okay, so this is a commit. This is a commit where we have tree parent, author, committer, and then a message. Okay, so that makes sense. Now, if I do our pigsy... Okay, so we want to go to Git, objects. This is going to be F150. Oh, so we're missing... So it doesn't start with tree, it starts with commit and then the size. Oh, so okay, we're missing the header for this. Rugmat, hello. How are you doing today? Where is Zilby? Zilby is down here. We went on break earlier where he was next to us on the table, and he decided, like he has been recently, to do his manager duties and force me into standing mode by taking my chair. And so that's where he is right now. And I don't really have a good way to have a camera on him for that. So unfortunately, we don't have a Zilby cam right now. But he is sleeping. I see his ears like going around when I say his name a little bit. So he is aware. Now I wonder if I throw this commit 264 null in front of what we got back, I wonder if that would make this a valid commit file. I wonder if that's all we're missing. So we just need the size, I think, of the rest of this, which we have. We have the size of the rest of this. And then we're missing commit space size null. Okay, so we're in clone. So before I can save to disk, I need to like let mute header equals. Oh, and then this is gonna be 2 bytes, right? So we're gonna have, oh, this is gonna be fun. Okay, so we're gonna have commit space. Oh, but this is gonna suck because I don't have the size. Okay, we're gonna have to format this. So I have commit space, and then I need the size. The size is the count here. So it'd be count. And then null, like that. And then I want this to be, I can't do the into bytes right away, so do header like that, and then I want to combine the two, so let our commit is going to be equal to our header into bytes, and then we extend the decompressed object. We've given ownership of the way of that. Okay, so we pass in our commit here. Oh, wait. Nope. I keep on thinking I can do this all in one go. So we have our commit like that, and then I want our commit. Okay, extend like that. Here we go. Commit, we've extended, we've done all our things. You assume the output of get size, but also the same as total out. It's I would hope that it's the same size, right? I would hope that total out and get size are the same, but we don't know. We're gonna find out, right? So if we do this, let's try it out. So we're going to save you. We're going to rerun you. No, we start with remove. Okay, so we rerun you. Okay, now 237 is our total size. So we want to see if 237 is what we got here. You're the new number here. Now, first of all, we'll just do our check to see if this works. So we'll do get cat file. Corrupt lose object in there. Okay, so that's too bad. All right, so if I do our pigsy again, we want objects 1C08, and we're going to look for 237. It's not. It's 158. Oh, of course, of course. However, this is looking a little bit better. Okay, so let's try. Instead of the count like that, yeah, we're going to use get size. So I'm going to use get size. Oh, I can't. Get size here. Object type. Get size. Unwrap. Okay. Let's try you again. Okay, so it's a different hash. That's good. Apparently it's been an hour already. Another ad is starting in around 3.5 minutes or so. So just I guess a heads up for that. We're gonna do a get. We're gonna get read cat file. You. Hey, it worked. Okay, get cat file. Okay, it actually sees the thing. So it is something we can just straight up throw and save to the file. So that works. Okay, great. So I need to update save file to take a path of where to start saving it. Okay, that's not too bad. We can do that. Now in save file or save to disk, we're just taking the content and we're assuming we're creating a new path buff here and then going into get objects. But if we take in a path, which would be a path buff, then instead of a new here, we're just going to update you, which means you need to be mutable. And so we just update you to say, we just start joining here and add to you. Okay. So now, why are you upset? Oh, function defined here. I broke everything. Okay, so save to disk. This is where I wish that I had optional. If I could have optional, or I guess it would be defaults. If I could have default paths, that would work for us here. But I don't know. It's going to be a thing. Okay, so where are you? So this is in clone. So here we have a path of where we're going to, which is this. No, not URI. Where do I figure out what the path is? No, I do. Target directory. So the target directory is where we start our path here, which I already have here. So target directory is our path buff, which, do I give ownership of this? I want to go to where it's used. Is that references? Yeah, okay, so I give ownership of target directory here. Oh, but does it implement clone? I don't remember if it implements clone. All right. We're going to find out. So target directory like that, and use of move value. Okay, so then we're going to just clone you here at input. Okay, and that makes you happy. But now we have a bunch of unhappy things. Like you take to, okay, so this is in commit tree. And I want to create a new path here. So I'm gonna path buff new, which just sets it up with what we have here. Okay, that should be fine. And then right tree, you have the same problem. Oh, and no more errors. Okay, we're good to go. All right. So if we run you now, okay. So we don't have everything in here. We need to go back to my desktop. We're gonna run you. All right, this creates 7B 8E. It did not create it here. Okay. So that did not work. I mean, I did save everything, right? Yeah, okay, so it didn't. Right. I'm not saving the path as, oh, look at the warnings. Okay, fine, I guess we'll look at the warnings. Oh, unused return value of path join, that must be used. Oh, huh. Yeah, that would probably be a good thing, wouldn't it? Yeah, that would be helpful. Did I wonder where it's I wonder where it's saved. Okay, that's cool. Let's fix that. So in utils, unused. Okay, so path join. For some reason I thought it mutated the path, but it doesn't, does it? What does return do? It returns a new path buff. Okay, so I need to. We can just shadow path equals that, and then that should work. Okay. Let's try this again. Okay, this is 7B 8E. Hey, okay, so we have 7B 8E, and if I do a git cat file p 7B 8E, there we go. Okay, so we now have a single commit written in here in an object. All right, perfect. Mohammed, hello. How are you doing today? Is my editor new of him? No, this is the Helix editor that I'm using, which it's a CLI editor, so like there's some similarities to it. It is a lot less, how do I want to put it? There's a lot less features, but also a lot less config that I need to do, and like some sensible sort of like defaults in there. So I like it a lot. It works really well with Rust. There's still a lot of updates I need to do to it to make it work with other things, which is on my list to do, which we'll eventually get to it. But yeah, this is the Helix editor. Okay, great. Does it support Rust debugging out of the box? Yes, you have to make sure that the debugger is installed. So if I do Helix health of Rust, you have to make sure that you have an LLDB VS Code installed for the debug adapter. But then after that, there's some commands you need to do in it, and then you can step through the code and you can do all that fun stuff. But yeah, so like it does support, it's written in Rust, and it's as far as I can tell, made by, well, definitely made by Rust devs because it's written in Rust. So I think that it's like first party support essentially. And I remember we went through and we tested and made sure it was working, but it's been too long and I forget how we did that. There is an entire, so if I come back to, where am I? Here. There is an entire debugger in here somewhere. Yeah, so I could like space GR, so space G, oh, debug. Okay, then I can like launch a target debug, you connect it to the debugging session, and then you can do your stuff, and you can set up breakpoints and other things. So it has all the stuff. I rarely use it though. Okay, so save to disk. Okay, so this save to disk is now working as expected. So it's time for us to now loop through and run into the problem that I think Asitsu you're running into, which is type 7 is different than the other ones. Other than that, we're also only handling commit types as opposed to literally any other type, which is gonna bite us in the butt pretty soon. Okay, so we have our cursed pack file, and now I want to probably loop, because we don't know when this is going to be done. So as long as there is something left for us to do, we want to loop through here. We're going to have to figure out how to end the loop. We want to get the object type. We want to, we probably should check to see if the object type is unknown and then crash at this point in time. So let's head into process pack file, and for object type, let's do is unknown. And I think I want to, or maybe we would just like panic if unknown. How about that? Panic if unknown. Unknown. We're not going to return anything. We're just going to match on self. If we're self unknown, we panic. We are unknown object type, and then anything else is a no object. Okay, back to you. So I want to immediately object type panic if unknown. Okay, that's fine. We want to get our cursed pack file position. We want to create a decompressed object. We want to create a new decoder. So I might want to actually, we're going to want to put this into its own file eventually. So we create our decoder. We want to read to end. Okay, we want to count. We want to seek that, create the header for whatever we're doing. Now, in this case, it's always a commit. So that's a problem. We're going to want to turn, we want to get, I want to create the commit type. Okay, so we're going to deal with that in a little bit. Commit, extend, get the hash. And then we can, okay, we'll just do our debug there too. That'll be fine. Okay. And then our pack file. Okay, that's whatever's coming out. So I don't need, oh, that's fine for us to debug out. Okay, so there's no way for us to exit the loop. So we want to, oh, right, a for loop. That's perfect. That's exactly what we want. Yeah, so we want to do for, I don't think we care about this, right? So for in 0 through the count, which is the pack file, object count. Okay. So go through there. Now you're upset because the target directory is, oh, we need to clone this every time. Okay. And now we're going to handle you. Okay, so this is going to panic if it's unknown, which means not a commit right now. And then the other thing is I want to make this a little bit more dynamic, which means I need you to be something like this, and I need a object type dot like header, like header string or something like that. I could also implement I could implement display for object type. Maybe that would work. Let's do this. If I do object type, can I do a reference like that? No, I can't. Yeah, okay, so we'll do this, and we'll just have object type dot maybe get type. That works. I could toString it too, as well. Oh, Claude, hello. How are you doing today? Okay, so come into here and we want to get type now. We're going to return let's just return a static string. You're fine, you said this time I won't salute you first. Salute you first? Maybe? I don't know. I'm like my brain is a little bit more scatterbrained today, so it's hard to remember like what I was said. Oh, I always say hi first, but this time you got it. Well, you got me. But that's a good kind of get, right? All right, so we want self commit. I don't care about that commit, what's in there, and then we're just gonna return commit. And if you are, let's just do self unknown. And in this case, we'll just do unknown, which is obviously going to cause a problem, but we already validated that it's something, that it's not unknown. So actually, you know what we can do? We can say this is unreachable. So that will cause a crash. Okay, so now that should work. Do I have a prettier for Rust, or is just an auto formatter unsafe? Yes. I think the answer is yes. So Rust format is the prettier for Rust. It's the official one from the Rust group, the Rust working group or the project. And I also have it set on safe. So yes to both. Unlike prettier, it's actually like for the entire project. So everybody with, you know, an asterisk next there, because there are alternate formatters that are either in the works or out there and released, and some people are using them. And you can configure it too. So it's not like 100% of Rust code is going to look exactly the same, but it's going to be close enough. I don't do any special things with Rust format. Okay, so that should work. Okay, this should be exactly the same now. So let's oh, this should be exactly the same, except we're going to crash as soon as we hit panic if unknown. So let's try it. So if we run U, okay, so we got 1, 2, 3, 4, 5 commits down, at which time we panicked. Unknown object type. Ooh, 5 commits in, which is all 5 commits they had. Nice. And I think these are actually saved to the disk, right? So we should be able to see all 5 of these. So 1, 2, 3, 4. So if we do tree, oh, LT, yeah. Oh, we only saw 4. Okay, so, oh, right. I think I got this wrong. So we have 1, 2, 3. Yeah, only 4 things saved to disk before we end it. So not 5, because this first hash was the same as this other one. So great, perfect. Now, does that match what we know about CodeCrafters here? We see four commits total. Okay, so all 4 commits have now been written out, and I should be able to get cat file and see we have wrong one. Get cat file. So we should be able to see 6526 7B 8E 882A and finally 21, no, B5 21. Perfect. So all the commits are now going in. Now, because we know that they're looking for a commit, we might be able to just trick. Let's see what happens. Let's not process the rest of it, and then see if CodeCrafters is happy with what we've got. At least having the commits in here, because obviously, I'm pretty sure they're not going to be happy because we don't have any files. Like when you clone, you usually also set to head and then auto checkout to whichever the one is the master branch, which we don't have. but maybe they're not testing that. I don't know. But at least we should pass where we are right now with them, which is they're trying to find this cat file. So perfect. Also, they're doing this git cat file commit. Oh, interesting. I've not tried that commit. Let's try it. This is git cat file commit b521. Okay, so it's the same thing. It works. Excellent. So let's if you're all working, I need to make sure it doesn't crash. So we want to handle this. So as soon as you become, okay, let's if, oh, that's a panic, isn't it? I don't really want you to panic. I want, instead of panic, let's is unknown or something like that, which I could do a match on. Let's just implement partial equal, and that will make it easier. Or we can do matches. Well, we could do matches. That will be fun. So if matches, now you're the thing and then whatever. Okay, then so you're the thing, so it's gonna be object type unknown, and then the matches is gonna be object type unknown. No, object type unknown and object type. I might have that backwards. It might have to be reversed around. Okay, so if it matches, I want to print line that we attempting to handle unknown object type. Let's print this out. Object type there. And then we're going to continue so we don't process the rest of this here. What are you upset about? Unused variable and matches. Oh, object type. I wanted object type in here like that. Huh, unused variable? I thought that's how matches works. Yeah, it's like bar. Oh, I have it the other way around. I have it backwards. So you should be object type unknown, like that. There it goes. Okay. So you're good. Not just the checkout, you also don't have the rest of the tree and blob object. Yeah, we're missing like, I don't know, 80% of what a clone really does. But what I want to do is I want to push this up and make sure that this step we were able to pass this test and we haven't regressed on anything. That's really what I want to test. And then in the meantime, let's go ahead and start handling all of these all these warnings and get rid of them. Variance hash branch name features are never constructed. I think that's okay. I'm not using those. And I don't know if I need these either. Okay, so in reader state, okay, so variance hash branch name features are never constructed. I guess if they're never constructed, they're never read. Okay, so in that case, I don't need hash branch name or features. And then these are never read. Okay, these are never read, but I do construct them at the very least. Pack file has a derived impl for the trait debug, but this is intentionally ignored during dead code analysis. Oh, interesting. Oh, right, because when we're debugging this, yes. So I probably want to allow, in this specific case, want to allow dead code just for these. And that's going to be okay. We're not using cursor there. Not using you. No more warnings, no more errors. This should still work. I guess we have a bunch of these debugs still. So the initialize git directory, I'm okay with that. The want commit, okay, so in clone, we're gonna remove the, okay, so clone line 25. Move you as a debug. And then 60. Which saves to disk. Okay, so I don't need that. I don't need this pack file here. I will underscore you. Okay. We have the attempting to handle unknown object type, unknown, unknown. And then we panic on corrupt deflate stream. When I continue, that's your type 7. Oh, interesting. I was thinking that I was going to handle this properly, but So what I was thinking is that this continue. Oh, so read type and size doesn't work with type 7. That's where it fails. Because if I put in like let's put in a debug about to read type and then debug read type. So if we do this, we have about to read type or about to read type. Oh, no. Okay, wait. We read the type. Huh. Try break instead of continue. For some reason, I was thinking that I would just like continue on in case there was other commits. But yeah, let's try a break instead. I still need to handle the type to get the correct offset to read the next entries. I wonder if that's the problem. I wonder if that is the issue. So if I break out of it, we just stop reading altogether. We're basically, it looks like the commits are all up front and then the rest of the stuff is afterwards. So this should work now. Attempting to handle unknown object type unknown, and then we quit out. Okay, perfect. So status. Why do I have an hash? Oh, I remember. Okay, so when I remove an ash history, I use this when we were creating, I used this repo when we were creating stuff for the Docker course. So that's why we have Ash history and then a busybox RC. We don't want you. A process pack file. I don't need the test file. And I don't need test file. Okay. All right, so those things should be good. So we're going to git commit. What did we do here? We are, I guess, saving, I guess, when cloning a repo from GitHub, we are saving the commits to disk. Let's go ahead and push this up, and then we're going to let CodeCrafters do its thing. So this is probably a good time to then remind, like, okay, CodeCrafters is a pretty cool system. I'm partnered with them, so that means that they gave me a VIP access, and I'm able to go through and do all these to completion. They didn't tell me that I have to, like, stop early or do anything else. So if you're content and like would just love like following along on your own without having to purchase from it, that is perfectly fine. If you do like CodeCrafters and you really like what you're seeing and you want to try some of their other challenges, then I do have a link for doing that. In YouTube, it's in the description, and then here on Twitch, it is under the CodeCrafters command that we have there. And if you do purchase, I do get compensated for that, which is why I click the branding button for the streams. Okay, so that worked. Okay, so that worked. We passed that test. So they ran git cat file commit, and the commit contents were verified. Perfect. Excellent. Reading contents of a sample file. So then they went to open donkey, monkey, and of course there were no files there. So they are requiring us to do the proper thing and actually restore, like, put the files and the folders into place. So we kind of need to do that. Okay, I mean, that makes sense. Now we have to read the tree. So how do we do that? We have to read the tree. Is it so you need to take off? Well, thank you so much for the help. It was a lot of helpful. It was a lot of helpful. It was a lot of help. Thank you for that, and have a great rest of your day. My words are starting to get mixed up, which is usually a sign that my brain is starting to get tired. But we can go on for a little bit longer, I'm sure. Okay, so how do we figure out what the files and the folders are? Well, if I remember correctly, this is the tree, the job of the tree. So if we take a look at the commit for this one here, which we can see down here. Each of these commits here. So if we cat, so what, git commit, no, git cat file commit, whatever the first one was, we see tree B4 D2D. So, okay, that's great, except we need the tree now, and we don't have it. So B4 D2 doesn't exist yet. So we now need to make sure we handle trees. Okay. Now, in here, in our process pack file, in object type, we probably want a tree with a usize for how long it is. The tree is type type 2. Okay, so let's try running this and see if the trees are now written out. But now I need to run all the matches and everything else here. Okay, so get type, oh, and also get size. This is kind of important. Self tree. Also, you know what? Instead of none here, let's have you panic, saying tempted to get size of unknown, because we shouldn't ever do that. And if we do, I want to panic so I know. Tree, we get the size out of here. And we return some size. Okay. Good to know. Now, if you're panicking inside of there, I can probably this will make it easier. We do some like this. Now you will become a sum here, and then we'll destructure, dereference you, and then send that out. Okay, great. We have commit. Okay, self. We have a tree, and this will become tree like that. Okay. No errors, no warnings. So now if I just run this right away, we run everything. We still have that unknown object type, but we should now have trees as well. And so if you come down here, so 1, 2, 3, 4, 5. We now have a fifth thing. Okay, excellent. So if I let's do our git cat file b4d2. I don't have b4d2. I wonder if one of these we have the tree on it. So let's do 516d. Oh, that must be a. Well, that's a okay. Get cat file p 516d. Yeah, that's our tree. Okay. So here's our tree. We have our mode. We have our what it is. This is a file. And then we have our directories. Okay. The problem obviously being that we're missing these other things here. So like dumpty is like 2D8F. We're missing like 2D8F. So this is like I can create this file, create content, which is at the root. Okay, it must be, this is at the root of the repo. And these are the folder, these are the root folders. Okay, makes sense. So I need to make sure we go through all the trees. I need to make sure we actually skip our content. So the continue would be really helpful at this point in time. And I'm really curious why when I break, it's fine. When I continue, it's not. Oh, because... Okay, let's put everything in there, because if it's type 7, we'll break. How about that? I think that's what Asitsu is telling us. So we'll handle that. Yeah, get size is failing for something. I think Asitsu was telling us that 7 needs to be handled differently, but the other ones are perfectly fine. And so we have 3 for blob, then a tag, then a delta, and then a ref delta, which means that we have a delta. Okay, that's fine. So 3 is blob. So we have a blob. We have a tag. We have a OFS delta. And then we have a ref delta. Okay, so 3. Can I just... Oh, you can't handle... Okay, you can't add these in. That's too bad. Oh, right, because it's just numbers. 3 will go to self blob. 4 will go to tag, right? 3, 4 tag, then 6 and 7. Okay, so self tag. And then we skip 5 to go to 6 and 7. So 6, OFS delta, and then a ref delta. Okay. All right, so get size. I want... Now, it would be nice if I could just grab out the size easily here, but I think I have to handle them all, right? I can't... I don't think there's a wild card for these. That would be pretty cool. I don't think I can do like star in here, can I? That'd be pretty amazing if I could do that. But expected identifier found star. Yeah, I don't think I can do something like unknown here. That's a identifier. Although, what if I did this? What if I did self unknown returns this, and then we do everything else, we have a size, and then you're going to return size. Type annotations needed. Where exactly? The sizes are all use sizes, right? Oh, but you're a... that. Why is any code... Yeah, that syntax, this would be amazing if it did work. Like, I guess this is an example of the compiler not being smart enough to see that literally everything else that I've done implements size or like has this size on it. And so unfortunately it doesn't do its thing. So I can use the or pattern, but I still have to write them all out, which kind of sucks. So I guess we'll just implement you, build a match arms. I want we'll get the size out of here. Pass in the size here. And then okay, so unknown, you become we had just unreachable. Okay, get type. These are those. Okay, so build a match arms. Okay, so then you wait, why is okay. We have oh, it did it again. Okay, so I already have a commit and a tree. I already have an unknown. So it's just these 4. I want let's grab you, paste you in here like that. You become lowercase, and then you'll be on your own. These ones probably won't ever, I don't know what these are. They need to be handled differently because they're these are like delta type things. Whereas these are like obviously files, folders, tags, that kind of stuff. Okay, so save you. Now what I want to do is I want to skip the deltas are weird. That's what we've learned. The deltas are weird. So break if you're an OFS delta or if you're a ref delta. So let's do a is delta or something like that. Okay, so we're gonna, I guess we'll just match. We can just, we can do a matches. So matches, we have our self here. And if you are object type, delta, or object type oh, it doesn't like that. Expect unit struct, unit variant, or constant found tuple variant. Okay. Oh, single pipe. Oh, right, because it's a match, not an actual normal or. Okay, so there we go. Okay, so is delta checks that now. So we have our back to clone. So instead of matches here, we're just going to do if object type is delta. So if you're a delta, attempting to handle delta object type. and then we get the object type, and then break. Okay. So now we do this. Ref delta. Okay, we got a ref delta, and we see that that is 7. But in the meantime, you know what? What if I just stay out here and we do a LT get sample 3, get like that. We have 1, 2, 3, 4, 5, 6 things now. Okay. So that means we have 4 commits, a tree, and maybe an object of some kind. Which is nice, but this is where we have to handle ref delta now. Great. Okay. So ref delta. Conceptually, there are only 4 object types. Can you do continue instead of break now? Ooh, we could try. Yeah, let's try it. I'm betting that no. I'm thinking that it will still crash, but maybe not. Yeah. Okay. Panicked. Okay. Corrupt deflate stream. So I think the problem, which did you mention it, or somebody had mentioned it? I think it was you. That the size is wrong. So like the way we're extracting things is perfect for normal types, but if the object type is a delta, then the size is not correct anymore, and we have to handle it differently. Esitsu, okay, probably. So now we know let's see, in here, I get the object type right away, and then, okay, so then we get the size here. So in keep bits, we grab, okay, so we grab you. And then read size encoding. Huh, none of these have unwraps in them. Oh, but you know what? I do have question marks. So read size encoding, I wonder if this is where we run into issues. No, wait. It can't be that. Because we see we're attempting to handle delta type ref data, and then the next one fails. So it's okay, so it's the next one that fails because the next one is at the wrong location inside of it. Okay. So we need to at this point in time, if it turns out that this object type is a ref delta, we need to do something else and like then speed forward in our pack file reader and either skip it or handle it at this point in time differently. Both OFS delta and ref delta store the delta to be applied to another object called base object to reconstruct the object. The difference between them is ref delta directly encodes base object name. If the base object is in the same pack, OFS delta encodes the offset of the base object in the pack instead. The base object could also be delta-fied if it's in the same pack. Ref delta can also refer to an object outside the pack, the so-called thin pack. When stored on disk, however, the pack should be self-contained to avoid cyclic dependency. The delta data starts with the size of the base object and the size of the object to be reconstructed. These sizes are encoded using the size encoding from above. The remainder of the delta data is a sequence of instructions to reconstruct the object from the base object. If the base object is deltafied, it must be converted to canonical form first. Each instruction appends more and more data to the target object until it's complete. There are two supported instructions so far, one for copy, a byte range from the source okay. Each instruction is variable, of course. Instruction type is determined by the 7th bit of the first octet. Oh, okay, great. Add starts in, okay, so break time starts in 5 minutes. Okay, so instruction to copy from base object. This is the instruction format to copy a byte range from the source object. It encodes the offset to copy from and the number of bytes to copy. Offset and size are in little endian order. Was the other one's big endian order? All offset and size bytes are optional. Optional? This is reduce the instruction size when encoding small offsets or sizes. The first 7 bits in the first octet determines which of the next 7 octets is present. If bit 0 is set, offset 1 is present. If bit 1 is set, offset 2 is present, and so on. Note that a more compact instruction does not change offset and size encoding. For example, if only offset 2 is omitted, like below, offset 3 still contains bits 16 to 23. It does not become offset 2 and contains bits 8 through 15, even if it's right next to offset 1. In its most compact form, this instruction only takes up 1 byte, with both offset and size omitted, which will have default value 0. There is another exception. Size 0 is automatically converted. Okay. This is to construct turret object without the base object. All right, original. I don't think we have original. I think we have like the modern stuff. Version 2 pack, okay. Oh, but these are IDX files. We don't have an IDX files. We have like an actual pack file. Okay, so this is fun. I kind of want to see what it is that we have here. Because clearly we have a delta representing the rest of the stuff. Which kind of sucks. Let's just read up the first byte and print it out in the case that it's this thing. So in clone, we're in delta. Continue doesn't work, so we're gonna have to break. But before we continue, let's grab the next okay, so I want the next byte. So we're going to do let mute next byte. So I just want one of you. Let's do our cursed pack file. I don't want to read end. I want read exact. Okay, read exact. Next bytes. And then I guess we'll print these out. So we'll just debug next bytes. Business Maker, hello. How are you doing today? What do you think is the best top-down? Okay, what do I think is the best? Top-down or isometric Metroidvania? Top-down feels... Are there any examples of top-down? Would we consider a Zelda game a Metroidvania? That doesn't feel like a... It doesn't feel like a Metroidvania. Oh, sorry. Ad break just started. I totally forgot that we were in the middle of this. Like Zelda 1. I'm talking about like the original OG Zeldas. Bizmaker, if you get an ad, let me know and we'll pause until the end, and then we'll continue the conversation right after that. Actually, you know what? We're gonna pause anyways because I need to go use the restroom really quickly. No ads for you? Okay. That's good. So I guess Link's Awakening, I never played the original. I've only played like the OG Legend of Zelda. And some of the other ones, but I never completed them. I always thought that oh, RO, you got the ad this time. Okay. I've never considered top-down anything to be like a Metroidvania. Even though I can definitely see elements of Metroidvania in there. So I can definitely see that. Isometric is like the remade Link's Awakening, right? I don't think that there's one is better than the other. I think that they both can be really good. I am terrible at Metroidvanias, by the way, so I'm a little bit biased against Metroidvanias, mostly because I get lost in them and I sort of like forget what I'm doing, forget where I'm going. I need a lot of player assistance inside the game to help me out. Otherwise, I just get frustrated with like the map and everything else inside of there. So that's the problem I have. We have 1 minute left on the ad break. I'm going to take a super quick, less than 1 minute break, and I will be right back. All right. Oh, thanks anyways. Hopefully I guess so that's my thoughts. I like both top-down and side games. I guess like top-down and isometric. I like both of those. So I guess I don't have any skin in the game is really what it comes down to. Are you trying to make a game and you're trying to figure out like which one to go with? Okay, so our next bytes, 182. So this is a U8. Okay, I want to turn this into binary. Can I do this with a format? Next, okay, let's, next bytes. Some byte like that. Maybe this might work. This might give us what we want. Okay, so here's what we have. We have our binary number 101101110. So let's see if we can figure out what this means. So instruction to copy. Yeah, okay, so instruction to copy from the base object. And these are 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the first one, right? So you're always going to be 1. Interesting, okay. It encodes the offset to copy from and the number of bytes to copy. Offset and size are in little endian order. Note that a more compact instruction does not change offset and size encoding. For example, if only offset 2 is omitted like below, offset 3 still contains bits. Oh, weird. Okay. So we have 4 offsets and then 3 sizes. So looking at that, we have always 1, and then we have offset 1, 2, 3, 4. And so we have offset 0, 1, and 2. Okay, so offset 1 and 2 are set for us. And then offset, I guess technically the way we wrote this here, offset 2 and 3 are set. And then 1 and 4 are zeros. And then we're going to have the sizes. How do I get the sizes for this? Because like obviously it's just 1 and 0, so that's not helpful. Does this guide have anything with ref delta in here? Yes, okay. Undeltified objects. Okay, so that's fine. Deltified objects. There we go. So far, we've seen how to find an object in a pack file and read its compression representation. However, we're still missing the main motivation for pack files, being able to save space by storing one object in terms of another. This is where the offset delta and hash delta object comes in. The idea of a deltified object is simple. The object is formed by combining chunks copied from a base object with new data. Ideally, the two objects are very similar, in which case only a few large chunks need to be copied and little new data needs to be specified. The only difference between the offset delta and hash delta types is how the base object is specified. A hash delta uses the object's 20-byte hash, whereas an offset delta specifies its position in the same pack file. Okay, now they're using hash delta. Okay, so there's offset delta and then hash delta. And up here, the 6, yeah, offset delta and then ref delta. So a hash delta, which is the ref delta, uses the object's 20-byte hash. Okay, an offset delta specifies the position in the same pack file. The offset representation is shorter and makes it easier to locate the base object, but it doesn't allow for base objects outside the pack file. We'll start by decoding at the offset of an offset delta, which is number 6. It uses a very, okay, but we have a number 7. So we have a ref delta. Okay, so we need to get the instructions are distinguished by the upper bit of the first byte. A data instruction starts with a 0 bit, while copy instruction starts with 1. Okay, so that's, oh, interesting. Okay, so a data instruction starts with a 0, which I think we saw here. Copy. Whereas down here, data. Okay, that's interesting. In a data instruction, the remaining 7 bits indicate the number of data bytes that follow. Okay, so but we're going with copy to begin with. A copy instruction is followed by an offset up to 4 bytes and a size up to 3 bytes to copy in a base object. Oh, okay. I keep on mistaking how this works. So if we look at you, those 4 are the offset. So we have 0, 1, 1, 0. So if we start with 1, 2, 4, that's 40, 42 is our offset. And then the amount of data would be 1, 2, 4. No, that's too small. That's too small. That feels weird. The max size of the instruction is 7 bytes plus the first indicator byte. The first indicator byte tells you which of the next bytes is available. If bit 0 of the indicator is set, the offset 1 byte is available. If bit 4 is set, the size 1 byte will be available. This is where, like, I wish that there was examples in here, because this type of math is, I don't know if it's like hard for me, but like it's hard for me without examples. I usually need it like solved first, and then I can like reverse engineer it a lot easier than me like figuring it out from this type of documentation. The bits themselves are not telling you the size. Okay, that's good to know, but I guess it's still not helpful to me. They're only telling you which of the next bytes you need to read. Okay, so hold on. This instruction to format a byte range from the source copy and encodes the offset to copy from and the number of bytes to copy. Offset and size are in little endian order. Little endian is left to right? I think it's left to right, right? All offset and byte sizes are optional. This is to reduce the instruction size when encoding small offsets or sizes. The first 7 bits in that first octet determines which of the next 7 bits is present. Oh no, it's right to left. If bit 0 is set, which is that one, offset 1 is present. If bit 1 is set, offset 2 is present, and so on. Note that a more compact instruction does not change offset and size encoding. For example, if only offset 2 is omitted like below, offset 3 still contains bits 16 to 23. And it does not become offset 2 and contains bits 8 to 15, even if it's right next to offset 1. Okay. In its most compact form, this instruction only takes up 1 byte, with both offset and size omitted, which will have default value 0. There's another exception. Okay. All right, maybe you'll have better. A copy instruction starts with 1. A copy instruction is followed by an offset up to 4 bytes and a size up to 3 bytes. Oh, bytes, not bits. And a size up to 3 bytes. Okay, to copy into base object. The lower 7 bits in the instruction byte indicate which of these offset and size bytes are present. For example, consider this copy instruction. So we have 1, 0, 1, 0, 1, 0, 1. Okay. Only bytes 0 and 2 of offset are provided. Okay, so we have copy instruction here. Only byte 0 of size. Oh, this is okay. So I've got it backwards in here. So this is the size, and this is the offset, right? No. Okay, I'm still confused. Okay, so it is right to left. Is this reversed? Is this a binary number reversed, where it has, this is the far left of the binary number, and then everything else is like backwards because it's little endian? I wish they didn't do that. Oh, okay. It makes it harder for me to like actually just print this out and look and understand what's going on. Okay, so we have, this is byte 0 of size is provided. Little endian is right to left, but the offset and size byte orders are correct in that picture. But wait a second, this is showing these three in this number here. This is the size, which would mean that this is the size. So I want of the next bytes, I want to skip one and then get the next one as the size bytes. And then I want the offset, which is skip, offset, offset, skip. Is that, am I reading that correct? Or is it actually opposite way around, where it's like, well, I guess in this case it would be the same because they're the middles, but it would be offset. So skip offset, take offset, skip offset, take size, skip size. No, you don't skip anything. The skipped ones are not present in the byte stream at all. The first byte after this is going to be offset 2, which would be that one. Oh, okay. So they don't put that in there. Okay, so we're going to have, it's not present. So by skip, it just means not present. So we're going to have offset, offset, size. Is that what we're getting? Offset, offset, size. Okay, you read that byte and call it offset 2. Is that, oh geez. Here's the lengthy implementation. Keep in mind, we are just repeatedly reading an enum delta instruction. Data vec. Okay, so we have our data vec 8 and then copy size. Okay, then offset 3, non size 2. What I guess like the thing that is just weird is the fact that, okay, why do I have to call it offset 1 and offset 2 when it's just, I guess like, does the offset numbers actually mean anything at all? And do I have to keep track of those? Or is it just, we have 2 offsets and do I add the offsets together? Like I'm still confused about that. That's the same reason the dev.to article example also only has 3 bytes. The instruction has only 3 bits set. Okay. And then here's our implementations for this. So we have our copy instruction flag, which is 1 bit shift left to the 7. So that's going to be that far left one. Copy offset bytes is going to be, okay, we have 4 of those. Copy size bytes, so 3 of those. Copy 0 size if it's nothing. Read an integer of up to bytes length. Okay, so read partial int. Now, do we have partial. We have the read. We had var int byte, and now we have read partial int. Okay. Reads a single delta instruction from a stream and appends the relevant bytes to result, returns whether the delta stream still had instructions. And so this gives me the result out. And then we have apply delta, which reads the apply delta instruction. Okay. And then we return the object type and then the contents as a result. The delta format seems unnecessarily complex to me. Why does it need 3 different variable length integer representations? If we ignore the details though, we can see that a delta is really a generalization of a diff. In fact, Git often uses previous versions of blob and tree objects as base objects for the next version's deltas, just like Git diff would do. Instead of comparing on a line-by-line basis, though, the delta works with individual bytes. The chunks copied from the base object also do not need to be in the same order that they were in. But the benefits are exactly the same. When the changes are small, storing a diff reduces the amount of duplicated data. So pack files really do give Git the best of both worlds. Storing blobs for every file at every commit makes Git checkout very fast, but storing them as deltas and pack files keeps them from taking up excessive space. Okay. So we're not... Interesting. So it's just the differences that are being stored, that are being returned to us, as opposed to every file. Oh, okay. Okay, so now we can fill in the remaining cases and read pack object. All right, so first off, we have to handle this type of stuff. And that's where our size problems are coming in. Because the sizes are, well, different, because we need to read them in a different way. Because it's inconsistent, yay. So really, in read type and size, I now need to create the type and then handle the size in a different way. Oh, and then grab the actual data out, which would be this here. We have our content type, we have our object type, which is going to include the size of it, and then we have the contents, which is a result. And obviously, this could be an option because only the deltas would have the contents. Right? Only No, I only care about the object. Okay, so I can get the object type and then the size, and then we read that in via different thing. Shoot, okay. Oh, no, I'm gonna have to take, I have to get the data for it right then, don't I? Wait, no, I don't. Do I? I need okay, so if you're this, I don't have the contents net yet. I have the okay. Am I able to grab just the size out? So like I need to get the content type, the object type here. So like no matter what, we need that. And so we get this. But then the size is gonna be vastly different now. I think it is. I think I still get the result size. Okay, so if I don't get this out here, I could get the size separately and then say, okay, now process it and get me the thing in another function, as opposed to all together at once. I think that's what I would need to do. So if we update you and just say, okay, keep bits, just do an object type, new that gives us an object type. Oh, but I need this. I need the size, but the size is different. Oh, okay. No, but this is fine. Yes? Or wait, does it not matter? Now my brain is breaking down. Okay, so we figure out that you're a delta. If you're a delta, I guess like I probably need to like check to see exactly what type of delta it is, because it's probably a different method of going through it based upon the type. Okay, so if you're a delta ref, no, not a ref. If you're a hash delta, which is number 7, all of this stuff changes. So this kind of becomes an else here. So I wonder if I want to do a match on the object type. So if we match object type, and then we'll probably have a function to handle all the like the different things here. Okay. So if you're commit, we're going to get the size. And instead of to do, I want to do these things, but maybe down here. So we just like maybe have a function handle normal object type, because yeah, we're going to take in, do I want to pass in the object type? I I do. I want to pass in the object type, but I could pass in the... I only have a reference to it, and I don't really need mutable ref. Okay, so we'll have the object type. So then I don't need the size here, or I pass in the string. I pass in the string at this point. That makes more sense. Okay, so then we have our size, which is a U size, and we have our object type, which is a str, and we return the hash. So the result with a vec of U8. And then all of this gets returned here. Right? Yes. So delete you, throw you in here. We have our hash. We're now going to return an OK with the hash. Oh, I need the cursor with the pack file. So we need the cursed pack file, which is a reader. So R, which implements read. Cursed pack file, oh, which you need to be mutable. Why don't you work? Method position exists for mutable reference R, but its trait bounds were not satisfied. Really? I thought I could do that with... Oh, do I have to tell it that it's actually a cursor as opposed to just an R? Maybe. Might be seekable. Okay, let's try that. Read plus seekable. I don't see a seekable here. Is there a cursor? No. Okay, so what if instead of R, we just say you are a cursor of what did we decide you're containing? A reference to U8. Okay, so then you're happy here. Asitsu, welcome back. Hello. Oh, cursor R would be fine. Okay. Ooh, but what type are you? How do I lock you down? Do I lock you down? Maybe. Object type, get size. Oh, I need object type. Oh, but I don't need to get size because now we have the size. So we have our size in here. We create our decoder with the cursed pack file, but we already have a mutable reference to you. The trait bound R as ref U8 is not satisfied. Cursor required for cursor to implement. I'll read. Okay. Oh, because does an array implement R? So read like that. Doesn't like that. Unless I need that to be something like that. Nope. The trait read is implemented for cursor T. The trait bound. Oh, wait. You need to be owned. Seek would be fine if you switch position with stream position. Wait, but seek would be fine, but I'm worried. I'm working on the zlib decoder right now. So, cursed pack file. The trait bound R as ref U8 is not satisfied. Required for. Oh, does it? Is that need to be reference to R? No. Does that change the error message? As ref U8. Oh, so we need to add in as ref. So plus as ref U8. Okay, so the trait bound R as ref U8 is not satisfied. Required for standard cursor R to implement standard IO read. One redundant requirement hidden. Required for mutable reference cursor R to implement standard IO read. I am Steve-O. Hello. How are you doing today? U8? Oh. Like that. There we go. Okay, we got it. Was I just not actually reading the error message? It probably actually had the brackets around it, didn't it? Okay, so that makes all of these happy. Now, get type. No method get type found anymore because now I have, we don't need this anymore. So object type, get type. So it's just object type now. So actually I can do this. Object type, and then we don't need the size because we have the size like that. So that makes you happy. Oh, target directory. So we need to pass in the target directory too. Target directory is, I think, a string, not a path. So that might be okay. Yeah, target directory is a string. When do I create the path? Apparently never. When did I create it before? I don't think I deleted it. Oh. Target directory. That's what it is. Okay. So target directory becomes a path buff. Okay. We can do that. So this will be a path buff. Here, we'll just make you like that. That makes you happy. You probably don't need to be cloned because we only have one of you in here. Curse pack file seek. Borrow move value, curse pack file. Okay, so curse pack file, I pass in. Oh, I was trying to pass in a mutable reference, but apparently that won't work. So here, reference to you. Oh, you need to be mutable? No. Hold on. You're fine. Bar move value, zlib decoder See, I do make you mutable reference here. You don't need mutable. Spam, hello. How are you doing today? Sometimes the brain just reads over stuff. I'm used to it. I do that all the time. Are you doing fine? Great. I am, my brain is definitely feeling it today, or at least this afternoon at this point. I think all the binary math is harder on me than some of the other things that we do. Which mostly is practice. That's usually what it is. Okay, so cursed pack file. Now I give you ownership of this, but then I seek you. But is cursed pack file a smart pointer? Can I actually clone that? Is cursor a smart pointer? You know, if I borrow you, so if I borrow you, you're upset. So the trait bound mutable standard cursor read is not satisfied. Okay, so you need to be mutable. But then, okay, cannot mutate immutable variable cursed pack file, cannot borrow cursed pack file as mutable as it is not declared as mutable, which this binding is already a mutable borrow. What? That feels weird, but that fixes it. Yeah, I think that's exactly what it was, Schemus. Okay, so now you're happy. So now I can handle normal object from this. It does feel weird, doesn't it? Okay, so this is going to be handle normal object type. Okay, size. So we have our size. Our object type is a commit. We have our cursed pack file, and then finally our target directory, which we have to clone. And then mismatch types, expected unit. Okay, found a question mark that you. We are going to let our hash equals to this. Okay. Size, we dereference you. Okay, and now we have our hash that. So now we want to do the same thing for tree, blob, and tag. So we get our size. Oh, but we learned that we can just do this here, and that should work. We're going to call handle normal object type, hand it the size, hand it the okay. There are cursed pack file. And then what are you? You're the target directory. So let's target directory and we clone you. What is, can you do all those with a pattern to avoid duplication? I pass in the label. So not like I can if I I have a label thing that I could call from object type. That seems a little bit weird. So, I mean, probably yes. Also, what are you upset about? Okay, so I can't actually pull it out like that. I thought maybe I can get lucky or get cheat, I guess, a little bit. Okay. Match arms have incompatible types. Expect to destruct. Wait, don't you return? Handle object type returns that. Oh, right. I forgot to. Nope. What? What did I do? Where am I? How did I go to the end of the file? Where? All right. Don't do multi-cursors when the other one doesn't match. All right. So I need to multi-cursor here. That. There we go. Okay. Right. So what is a normal object? So a normal object in this case is a commit, a tree, a blob, or a tag. So normal in the context of a Git object. And so all of those are actually just files that we can store into the .git/objects directory. But we have offset delta and we have a ref delta, which are themselves different, and we need to handle them differently, which sucks. So this is how we can handle our hashes. So this exact same thing should work here. So I should be able to, I guess right now we're not doing anything. So I will underscore that. We have our handle type. I've quit everything else. Yes, everything else in this function is gone already. So now, no, this is not gone. So let's. Right now, I'm ignoring the pack file. I guess I'm ignoring things if it's a delta object, and then you just crash as soon as we handle that, which is kind of the same thing that we're doing right now. We're just breaking, but then that's the same thing. I guess it's not really the same thing. We're breaking is just the skipping it, which is here. Okay, here's what we can do. Function handle OFS delta. I don't know if these need to be different or not. Function handle. I'm pretty sure they do though. Ref delta. Now these, I think we get the size, but I think we don't care about that. Now I could call this, but it's going to crash when it comes back around to try to handle it. But we'll just call handle OFS delta. Now you're going to start yelling at me because the hash is not the same, which means that you need to be probably a sum here. Okay, so we have a sum hash. Okay, which means that you all return. I don't know what these are going to return. Like I don't have what the other thing is. So we're going to say, I'm going to multi-line you. Return a none. Cool. Okay, so I have to handle the size, so we have to do that. We'll do the same thing here. So we'll handle ref delta, then return a none, and then if you happen, we're going to do unreachable, because it technically should be unreachable at this point in time. Okay, and then errors. Semicolon U. Wow, it's been an hour already again? Oh, crazy. Time does fly during these streams. At least for me. Okay, so this should be exactly the same right now result that we get, which is we crash. Called result unwrap on error, corrupt deflate stream. Okay, so we crash at this point in time. Time flies when you're having fun. Yeah, although like even if the fun is breaking my brain, like that's definitely something that happens. Okay, so what I can do now is we can start playing with you. So we can say ePrint line attempting to handle OFS delta. Attempting to handle ref delta. And I believe it's the ref delta that happens right before we crash. Attempting to handle ref delta, and then we crash, and it's terrible, and it's horrible. Okay, so then this point in time, is there something that we can, is there a jump point for this? Delta instructions, not really. So let's do at that. So that way it's a reminder for me of what to do next time. I'm gonna go ahead and snooze the ads a little bit. I don't actually think that I'm going to let the ads play. I think we're going to end right before then, because I don't know if my brain can handle the full going through, and this feels like a lot, and I think I should be fresh when we try to do this. So the plan is next week on Monday, I'm going to see this, and we're going to go through this. We're going to implement using the Delta instructions here. We'll come here and we'll see the Delta instructions, and we have to implement all of these and potentially all of this stuff, which is fun. So that's going to be interesting, and sort of like try to figure out what the heck are those things. It's from what I can tell reading through this, they're diff objects, which are not the same as the other thing. So we might have to do new gets or something else to figure out like what exactly we have. But that's a future me problem. So in a week when I ask, okay, what am I doing? How did I do this? What's going on? I can thank present me for basically saying, I don't want to do this now. All right, let's see. That's, I think then we can just call it a day. Let's go ahead and get this sent on up. Obviously this is not working right now, but we're a lot closer. Also, I keep on having this test file saved. Why do I have a test file? I don't want buffer close U. Oh, right, because I have this dev save the file, which I don't want anymore. So dev saves file, remove view. Okay. No more warnings, no anything else. Let's remove test file. Let's get commits. All right, so what are we doing? We are handling basic object types. Also prepped to handle ref type. Not ref types. They are... Snooze one more time. They are delta types. Okay, we'll go ahead and push this on up. Obviously, this is going to fail, and that's okay. And so with that being said, I think, yeah, crash, which is perfectly understandable at this point in time because that's exactly what's happening. Okay, I don't think I have anything else. We've saved the code. I think I got everything else up. Next week, we'll continue on with this. Tomorrow and Wednesday, we're working on the Docker course. And we left off where the Docker, we've written all the first path-throughs for the articles. So now we're at the point where we're going to reread the articles, make sure that they make sense, and then create videos for each one. And then the course will be done. So I don't know if we'll be done with all the videos by the end of this week. So, you know, tomorrow and Wednesday, we have long days. So we might get all the videos done, but next week might be more safe to know. And once those are done, I get to upload them, put them on the LMS, and we get to start selling. So anyways, everybody, thank you so much for hanging out today. Hopefully you all have a great rest of your Monday. Oh, a lot of people are streaming right now. Okay, who should we raid? At least on the Twitch side. Let's see, Teach Dev is streaming. I guess the person who has the least number of... CM Griffin is making Vexilla, which is a feature flagging for everyone. And CM Griffin raids us every once in a while. So I think it's been a while since we raided him. Let's go ahead and set a raid for CM Griffin. So I'm going to do a raid. CM Griffin. All right. Everybody, thank you so much again for hanging out with us today. I hope that you all have a great rest of your day, and I will see you next time. Bye.